So today, in a few minutes, we're going to start looking at the first part of the linear lab as it pretty much pertains just to slope. But before we do that, a couple of things, make sure that y'all know about. I sent out an announcement this morning about a couple of updates, but the main idea of those announcements. First order of business. Probability and Statistics Lab 3 is due tomorrow night by midnight, both parts. Again, we are not going to have too many more assignments. So what that means is if you're not where you want to be points-wise, you really can't afford to miss any of the work entries if you're not where you want to be. And on the other side of that coin, if you're doing it exceptionally well, you've more than likely built up some insurance where like, I'll be all right without this one. But that is a risky gamble. So, just be very, very careful. And of course, that only holds true to folks that are still enrolled in the class after the 9th, because that is the last day to take yourself out of a class. Now, I wanted to try and wait and not do any drops until that date passed, but some folks have kind of already, forced my hand based off of like attendance or other things. So I just kind of had to go on with that. But the main thing to remember about Probability and Statistics Lab 3, you have to do the work entry on this part. It is not optional. Okay? 1, 2, and 3 are graded on your work entry. Okay? 1, 2, and 3 are graded on the work entry for this lab. You have to do it. It is not an option. Yes. Yeah, that's all you need for the work is just 1, 2, and 3, because the rest of them, there literally is no work to do. You're just answering questions and doing it that way. The only thing to watch out for on the answer entry is that since the answer entry is where you do 4 through 12, they are numbered 1 through 9 because it wouldn't let me start the numbering custom. So just be aware for that, and I put that on there too. And I've even got on the work entry how many points apiece each graph is worth. Okay, so that's due tomorrow night. Make sure that you get that in by then. Looks like for now I got a handful that have, handful that need to get it done. But you still got time, so you're good. This opened today, the Probability and Statistics test. It is the only thing that is opening new this week. I know that I opened up the first part of the linear labs, but that's just the content. The assignments themselves will not open until next week. All right, you got one thing due tomorrow night. You have another thing opening up today. That's 2 things. I did not want to overwhelm you, so 2 is plenty. Just remember, the tests are online. You do them at your convenience. Some folks need to have a separate testing area. They don't like to take a test in class. It makes them anxious. So yeah, there's that. Okay. And you got 8 days to get it done. So if anybody has an extended time accommodation, 8 days should scratch that surface. All right. And again, I'm kind of talking to the folks that have fallen behind and not turned stuff in. If you can't get something turned in 8 days, that's over a week, and there are still people like, oh yeah, it's too much, I can't do it. Like, okay, my bad. Next time I'll give you 2 weeks. I really won't, but whatever. All right, and the test review that we did on the first, I recorded it and I linked it in the test section. So if you need to go back and look through that, go ahead. There are 25 questions on the test. So you need to make sure that you set yourself some time for this. I've had folks this year open up a test. They'll send me a message that said, I went to do the test and then time ran out. You know what that tells me? A lot of things. First of all, it tells me that they don't know how to not tell on themselves. Because if it timed them out, they started it at like an hour or 30 minutes before it was due that night after they had 8 days to do it. So they procrastinated, right? But, they try to pass it off as a Moodle error. Like, no, it locked you out because you wasted time and didn't get it done. I know some folks work and everything, but, tough. That's how it is. So this opened today. It will close. Both parts will close on the 14th. Now, again, like when I was talking about the syllabus at the beginning of the year, why are there certain weird things in the syllabus? Same reason why, a hairdryer's warning says don't use this in a shower, or why roll-on deodorant says do not eat this. All right? They have to put that on there because somebody did it. All right? These parts of the test count more than the regular labs. That is on purpose, to where if you miss one, it counts more. Okay? So that's why, like, I've had folks, it's like, they didn't do the test. And they just thought, well, okay. Especially like the finance test, if you missed that one really hurt you, because there was no work entry for that, so it was worth 150 points. So that was tough. So please make sure that you do both parts of the probability and statistics test. Yes, the work entries are still semi-optional. Okay, I don't want to go away from that, but again, you need to make sure that you're taking advantage of every opportunity. The description says, here is where you'll upload your handwritten work for all non-scatterplot and non-correlation problems. The correlation problems won't have any work, right? They're just, what is it? What type of correlation was this making? You just read it. The scatterplots, I think, if I'm remembering correctly, I think the scatterplot questions are ones that are already made, and you just have to tell what's going on. I don't think you're going to have to make one. I think you're just going to be reading them this time, because that's the easiest way to do it. Yes, you won't have to do that. Instead, you'll be looking at ones that are already made and answering what's going on. So it should be a little bit simpler. All right. Okay, so that's open now. Again, look at the due dates. By the way, does everybody know where to find the due dates on assignments? Yes, yeah, it's right there. Again, it's like, I didn't know when it was due. Did you not? Oh, I'm sorry. It wasn't highlighted in yellow with, JavaScript graphic arrows flashing, pointing right at it. All right? What is it they say? You can lead a horse to water, but you can't teach it how to read. I made that part up. Hey, Gwen. All right. So, yeah, you still got plenty of time to do that. What I want us to do today is we're going to start looking at the first part of the linear versus nonlinear section. Initially, I just had this as one kind of big section, but I've broken it up into two because after talking with Miss Wilson, the 043 teacher, she said, it might help if we just did one part on slope and then do the rest of it in a second part, which is a good idea. So I've broken it up. We're going to be looking at the slope for the first of this. Again, the assignments for this section, I need to make sure everybody knows this. The assignments for this section will not open until next week. That's why they're due the 21st, okay? They will not open until next week because I did not want to overwhelm you, all right? So, let's get down to brass tacks here. All right. So click where it says linear versus nonlinear notes. All right. Whether you want to open it up in another page or not, that is up to you. I'm going to be adding a lot of stuff to the board today, so you might want to make sure that you get that done. Get that down. Sorry. I was stuck in whip cracker mode there for a little bit, and I forgot what was going on. Okay. Evidently, my internet said there will be no notes today. Is this doing this for any of y'all? It worked fine this morning. Here it comes. Okay. The internet is a fickle mistress. It was just, it would have been totally non-surprising to me that everything worked like a charm when I went out to Andrews High School this morning and then doesn't do crap when I get here. Yeah. I mean, there's not enough internet for everybody, so gotta get in line for that good internet. Otherwise, you get the 2-day-old internet. All right. Which, by the way, total side note, found out 2 weeks ago when we were at church that the reason why people say crap is because there was actually a guy named Crapper that made an improvement on the original design of a toilet. So when they're saying they're heading to the Crapper, it was because it had his name above it in a plaque patented by Thomas Crapper. The more you know. That's a good piece of party trivia. Did you know? It's like, I didn't want to know that. Shut up. Okay, so we're going to be looking at linear versus nonlinear functions and graphs. We're not going to the book yet today, but if you wanted to look in the textbook, it is in sections 8A, 9A, and 9B that our information comes from. And again, we will look at that in some more detail towards the end of the week or maybe even next week. All right, because slope, there is a lot of stuff to it. Okay, and depending on how far removed from high school you are, you might remember it better than somebody else. All right, it's one of those things where it's literally, if you don't use it, you forget it. So we're going to kind of go back through all the important stuff about this. We're going to add some notes to the board. That's why on the video I've got it split to where this will be showing up in the bottom right corner. All right. So when we did scatter plots last week, we talked briefly about the difference between independent and dependent variables, right? Independent, it's going to do what it wants to do. Can't really do nothing about it. Whereas dependent is kind of, the name says, it depends on what X is doing. That is more true with a linear relationship, okay? So when the independent variable, which is X, and the dependent variable Y have a functional relationship, that makes a straight line when graphed. You say it is linear. So when it says functional relationship, think of that meaning X tells Y. No, that's not right. Let's see. Let's rephrase that. Because there actually is a function. I'll forget it's cleared out. All right. The function determines what Y is made from X. There we go. That's much better. The function determines what Y is made from X. Okay? When I would cover this when I taught 8th grade. Oh, crap. Sorry. When I would cover this when I taught 8th grade, I would tell my students, think of the function, which would be the equation in this instance, and we'll look at it here in a minute. But I would tell them, think of the function like a factory, or more like a machine in a factory, and think of X as your raw materials. Okay? The raw material goes into the machine fiddles with it, makes something new. Right? It's like saying, if you get the materials needed to make rubber, you run it through the machine, what comes out? A tire. Right? So the rubber, X, the machine is the function, and then the tire would be Y. In other words, X goes in to the function, Y comes out of the function. Okay? And I know somebody's going to be looking at this and like, that's not how tires are made. Just go with the metaphor, okay? I'm a math teacher, not an engineer. All right. It's built off of something called slope-intercept form. Okay, and we'll cover that next here in just a second. But slope-intercept form is going to be how the functions are written. All right, and we'll go into more detail in that in just a second. So a linear growth rate, which will be this last little piece right here. a linear growth rate is changing by the same amount with each independent variable. In other words, that is what is called a slope. Okay? If it has a slope, that means that the change is constant. It's not random like it is in a scatter plot. Okay? So, if it's changing by the same amount, what it is you can predict expertly what it's going to be at a given x value. Because it's going to make a straight line, right? Any questions so far? Anybody still jotting some stuff down? Okay. All right. So the first thing that we're going to throw up on the board, can I clear this out, by the way? Okay. First thing we're going to throw up on the board is some more information about slope-intercept form. Okay? So, and then we'll kind of backtrack when we talk about slope. All right, so notice it says number 2 on there because we had to explain what linear meant. But on the board, let's talk about slope-intercept form. Okay? Now, slope-intercept form, like the notes page says, it's the model used to build a linear equation. Okay? Now, the first time that you learned it, you probably remembered it as y equals mx plus b. Right? Okay. There's nothing wrong with that, except for one teeny tiny little thing. You see where it says plus b? The b, and I'm kind of skipping ahead a minute, but it's okay. The b is the variable used for something called your y-intercept. Okay? If you remember anything about a coordinate plane, so here's y, here's x, okay? When we did scatter plots, we stayed in quadrant 1, right? Quadrant 1, all values of x and y are what in terms of positive and negative? They're all positive, right? So it's positive, positive. So that's positive, that's positive. What about quadrant 2, which is over here on the left? For x and y, which one are there positives, negatives? How's it arranged? Right, because if this side of x is positive, this side is negative. So negative, yeah, that's a bad comment. Negative, positive, all right? Because you always put your x value first. Here is quadrant 3. All right, how are they arranged in quadrant 3? If this part of y is positive, what's this part? Right. So that's negative, negative, which means that quadrant 4 is what? Positive, negative, good. So, I know I beat this phrase to death, but I told you all that to tell you this. The fact that you could have your y-intercept be positive or negative means that we are going to use y equals plus or minus a. Because sometimes your y-intercept is negative. Okay? Sometimes it's below the x-axis. So if it's below the x-axis, it's negative. All right, so I like that because it's a little bit more referential in that, oh, I've got a negative y-intercept. Oh, my formula said positive. Problem. Like, no, it didn't. It said plus or minus. You're good. All right. Moving right along, another thing to remember about slope-intercept form is that even though it says slope-intercept form, it works more like a formula, okay? When it's called a certain form, it means that it's a way to write it down, okay? So, fractions, that's fraction form. Decimals, that's decimal form. Percents, that's percent form. See where I'm getting with this? So if you are asked to get the equation of a line, then technically, yes, you do write it in slope-intercept form. But flip that around. Let's say that they don't know the graph, they don't know the line, but they have the equation in a function table. Well, that equation is written in slope-intercept form, but slope-intercept form works as a formula because, again, the x values go in and the y values come out. So, what do all these letters mean? Okay, so do I have 4 different colors? Why, yes, I do. All right, so y equals m x plus or minus b. Okay? Y equals mx plus or minus b. So, let's talk about what all this stuff does. Okay, first off, let's just go left to right. Okay? Y is your output. Okay? Y is your output. Or like the notes say, Y is your dependent variable. X goes into this, which is your independent variable, and then all this stuff is done to it to determine what Y is. So Y literally depends on what happens to X, and it depends on what X is. Okay? The next one is our slope. Okay? M is your slope. The constant change that we were talking about, because it's constant in that between each point they are going to be this distance apart from each other, and that's really all slope is. It's the distance between your points. Oop, wrong color. X. Shoot. I made a mess. X is your input or your independent variable. When we have function tables, they will give you the x's and say, here's the x, run it through this function, tell us what the y is. Okay? Now, the b, the plus or minus b, which I guess I could really do this if I wanted continuity. Yeah. So the plus or minus b, we mentioned this earlier. This is something called your y-intercept. Okay? It's sort of like it sounds. It's where the line crosses over your y-axis. Okay? And again, the reason why I put plus or minus b is because there's 2 sides of the y-axis, the positive side and negative side, right? Okay. So, any questions about all of that? A lot of information in this first part, so I guess it's good that we broke it into 2. All right, so now let's talk about slope. Okay. Now, I'm trying to remember everything that I wrote on the board up at Andrews this morning, but then I realized, well, the reason why I had to write as much on the board as I did is because I can't write on the screen up there. So, I'm okay so far. But one thing I did tell them that I want to make sure that, I tell you guys, and then it gets on the video for this. You know how when we, going back to the percent lab and, the probability lab, and how there were a whole bunch of formulas, but they were all separate. You had a formula for an increase. You had a formula for a decrease. You had a formula for a markup. You had a formula for probability of events not occurring. You had a formula for theoretical and relative frequency probability. And they were all separate, right? The reason why folks get kind of turned around with the slope stuff is because on occasion, and we're going to see this on Wednesday, on occasion, there are going to be questions that ask you for something, and then you realize, oh, if I'm going to do this formula, I have to do this formula first. Or I've got to go back and do this one first. It's formulas within formulas. That's why this is so hard for some folks. It's not like, oh, I've got a separate formula for this, got a separate formula for that. They're not going to mess with each other. No, not this time. On this, on occasion, if there's something that you need for a certain part, there might be another formula that you have to backtrack and do first. And in most of the cases, it is slope. Okay? The absolute kind of hardest and most involved question that we're going to see in this section is a type of question that says, here are these 2 points, I want the entire line. I want the entire equation. Okay? So in that one's, there's like 3 formulas involved. So we'll get to that either Wednesday or next week. Okay, so back to the notes. I do that every week. All right, let's do this here. Okay, so slope is how the y-coordinate or the dependent variable changes in relation to the x-coordinate or the independent variable. Okay, so it is a change. Wait a minute. Sorry. It is a constant change between y and x. And I wrote it that way for a reason. Because slope, by definition, is your vertical change over your horizontal change. Boy, I'm not winning any points with handwriting on this one. Okay? It's your vertical change or your horizontal change. Or your change in y values over your change in x values. Okay? The formula for slope says m equals y2 minus y1 over x2 minus x1. You cannot find the slope of the line without less than 2 points, or with less than 2 points. You have to have 2 points. Now, yeah, I get it. There's going to be questions that say, all right, here's the slope, here's this point, find the y-intercept. That's down the road. We'll get to that in a little bit later date. Because today we're just going to focus on finding the slope and how it relates to other things. Okay? So what does this mean? Where do these numbers come from? Well, that's a good question. Glad you asked it. So let's look at an example here. Okay, and I'm just going to kind of slap it in right here. Not really much organization going on. Let's say that you got 2 points. Okay, let's say you got 1, -2, and -3, 4. Yeah, I just kind of slapped it together. Okay. What do you guys think, if you kind of remember doing slope in the past, what do you think some of the most common mistakes that were made involving slope would be in terms of using the formula? Okay, yeah, switching your coordinates, getting them put in the wrong spot. Yeah, that's the biggest killer. It is. I've seen things like, like Alex said, putting x1 and y1 in the wrong spot. I've seen folks that think this point here, 1, -2, is where x1 and x2 are. No. So the best way around messing this up, and it's not foolproof, because I messed the first one up that we did out at Andrews this morning because I was thinking about something else and got sidetracked. Label them. So here is x1. This is not x2, it is y1. Here is x2, here is y2. Okay? The first ordered pair contains your first x and your first y. The second ordered pair contains your second x and your second y. Okay? Even still, guys, you've got to be careful because I've messed these up before. It's really easy to do, which stinks because you would think that a formula this simple would be so easy to mess up. But it is. It can be done. It will be done. Okay, so substitute this stuff in here. Okay, so y2, all right, that's 4. Minus y1, so minus -2. We'll fix that in a minute. I know it looks weird, but we'll fix it here in a second. So the fact right now that it says 4 minus -2, that's right. That's correct. Right step. On the bottom, it's going to say -3 minus 1. Keep your minuses on the first substitution, okay? When you substitute these in, keep the minuses as a placeholder so that you don't lose them because they are very easy to lose. Now, like I said, I know that 4 minus -2 doesn't look right because it's not, all right? You got to think back to adding and subtracting, multiplying and dividing negatives, okay? If you are subtracting a negative, that is the same thing as adding a positive, right? They're opposites. Yeah, you can draw a line through the middle of both of them. That'll fix it, yeah. But, you know, got to do them both. You can't do one or the other or it's going to mess it up. And then the bottom one, -3 minus 1, that one's okay. So then, got to think back to your adding and subtracting integers rules. The way I used to tell people to do it, think of the codes, you know, AA and DS, okay? AA, if lines are alike, you add them together. So for this top one, 4 plus 2, they're both positive, right? So you go ahead and add them together. However, the bottom one, you got -3 minus 1. Well, that's the same as saying -3 plus -1. So that's, again, they are alike. So you just treat it like that. You add the values and keep the sign. So that's going to make -4. All right? Now, slope likes to be in its lowest possible form. If you have a negative in the top or the bottom of a fraction, the whole thing is considered negative. All right? If it's in the top or the bottom of a fraction, the whole thing is considered negative. If it's in both, you factor it out and it's positive. But 6 over 4, that's going to chop down to -3 over 2. Okay? Now, a couple of things about slope that I do not have room to write on the board. So if you want to try to jot it down, please do. If not, you know, on this recording, if you want to catch it back. Slope likes to be a fraction. Loves it. Okay, slope likes to be in fraction form. Because what is slope? Again, slope is a set of directions. Okay, slope is the directions and distance between each point on that line. Okay, so what this is telling you, if you were looking at this to graph, you've got a negative slope. Okay, so negative slope means I can put that negative in the top or the bottom. What does that mean? Well, the top number is your vertical. If it's positive, you're going up. If it's negative, you're going down. The bottom number is your horizontal. If it's positive, you're going to the right. If it's negative, you're going to the left. When I write these, I try to never go to the left. The only difference would be would be going up or down, and I'm always moving to the right. That's just easy for me to remember. If it doesn't bother you, then it doesn't bother you. But like for this instance, this is saying that from 1, -2 to -3, 4, I can go down 3 over 2 and then go down 3 over 2 again and get to it. Reason being because we had to reduce it. But Any other point on that line, yeah, down 3, right 2, there's my next one. And so on and so on and so on for the continuity and infinity of the line. Because that's what lines do. They go on forever. Any questions about finding slope? Okay. All right, let's press on here. Y-intercept. Okay. We briefly talked about y-intercept. Y-intercept is where the line will cross the y-axis. And we talked about how it will cross either above the x, which is a positive y, or below the x, which is a negative y. Okay? The reason why it gets the letter B, nobody really knows for sure. I mean, I'm sure it's written down somewhere. But what I've always told people is for 2 reasons. One, because y is already being used as your output variable, right? And you don't want to have it in 2 places, because if you've got the same variable in 2 places, that means the same number is showing up twice. And that'll cause all kinds of problems. So they gave it B. Now, I don't know why they picked B. I do not. But I do know this. They picked a letter before y, m, and x to signify one thing. And that one thing is that B, or your y-intercept, is the starting point of your graph. Okay? There's a phrase I used to tell my students with y-intercept. I'll just write it here because I'm out of room over there. Y-intercept is last in slope-intercept, or last in the formula, but it's first on a graph. Okay? So slope-intercept, or y-intercept, sorry. Y-intercept is last in the slope-intercept form. Last in slope-intercept form, but it's first on a graph. Okay? So when you're looking at an equation, if you're reading it as, y equals mx plus b and so on, well, the b is at the end of the formula. But it's going to be the first thing that goes on the graph. Okay? So like say if you've got it, just a quick little graph here. Okay? So like let's say that you've got, let me just make this a little bit bigger just for a minute. So like let's say you got just a quick little coordinate plane, and the problem tells you that you've got a slope of 1/2 and you've got a y-intercept of -2. Okay? This is not the scale, but just bear with me. So what this means is you're going to start at -2 on the axis itself. And then you're going to walk the slope to the second point. So -2 is where I start. My slope, my directions, are saying that I'm going to go 1 up and 2 to the right. All right? So from there, I'm going to go 1 unit up, 2 units to the right. There is my second point. And 2 points is the bare minimum you have to make a line. Got a line tool here. So let's just, there we go. All right. Easy peasy. All there is to it. Okay. The hardest part about graphing points is getting them if they're not given to you. Okay? Or, like let's say, if you are given the points and you don't know the slope or the y-intercept. Okay? But once you got all the pieces, then you're good to go. Okay? So, but yeah, slope-intercept, last in the equation, first on the line. Because what this equation would say here is y equals 1/2 x minus 2. Right? That's what that equation says. Last in the equation, first on the graph. So we'll put that on hold for now. Let's talk about function tables for the next little while. Still got some time. Okay. Anybody got any questions about y-intercept? Anybody need to finish writing all that stuff down? I know it's kind of messy looking. But it is what it is. Everybody good on that? Anybody still copying this red and blue part down? Okay. Moving along to function tables. So, when we have function tables, what they do, we talked about this at the beginning, x goes in, y comes out. So what happens is, it tells you, all right, here are your x's. Okay, so you've got your x's right here. Okay, it says here are your x's. Put them into this function and get me some y's. Okay, or here are different amounts of wheat. Tell me what different cereals it would make as it goes through the assembly line. Okay, so your formula, your slope-intercept form, y equals 2x plus 4. Okay, when you have the formula in slope-intercept form, here's what it does. It becomes a substitution problem. Remember substitution problems? They first introduced them to you when you're in elementary school, and it says stuff like, if you're doing a plus b, then what is, it says, I'm reading it wrong. It says, if a is 2 and 3 is 4, then what's a plus b? Yeah, that's how it went. If a is 2 and b is 4, or 3, whatever, what's a plus b? So you put those numbers in for those letters and then do what it says to do. Same idea here. You're going to take these x's and you're going to throw them in where it says x in the equation, right? Okay, so like for negative 2, you're going to do 2 times negative 2 plus 4. Well, then you're just back to order operations, right? That's all it is. So you're going to take the negative 2, multiply it by 2 to get negative 4, and then negative 4 plus 4 makes a 0. So now x goes in, y comes out, and you can get an ordered pair that way. Okay? Now again, what's the bare minimum that you need to make a line? 2. Most of them will have, some of these have way more than 3. I've seen some that have 4, 5. If you can't get it from 3, 4 and 5 is unnecessary. But anyway, that's just me. So yeah, when you have problems like this that says, here are your x's, here is your function, run these x's through the function. Right here? Yeah, negative 4 plus 4. Yep. Yeah, so negative 4 plus 4 makes 0. Okay, 0 went in to this one. 2 times 0 is 0 plus 4 makes 4. Now, something I want to highlight about this point here. For Pete's sake, I hit the wrong stupid thing. This point here, 0, 4. Okay. Remember when we talked about y-intercepts? I hope so. It was 5 minutes ago. Y-intercepts have 0 for their x values. Okay? Y-intercepts have zeros for their x values. So if you see one spit out like that, where your x is 0, then you know, oh, here's what my y-intercept is. Because they have no horizontal coordinates. They sit directly on the axis, right? Same thing for x-intercepts. This one above it, negative 2, 0, is an x-intercept, which means it has no vertical movement because it sits on the x-axis, the horizontal one. We just don't really do as much with those as we do the y-intercepts. Not as important. Sounds mean, but they're not. Okay? Same thing here with number 2, y equals x plus 5. Sorry, y equals x minus 5. Now notice how this one looks a little different than the one before it. What is different from this one and the one before? It doesn't have a slope showing. If the slope is not shown, like if you see a variable just by itself, what is implied is beside it? A 1. Yeah, a 1. If there was a 0 beside it, it would just say -5. It would kill that x. That's okay. That's why we're going back over this. Don't worry about it. Yeah. Now, is it going to bother me if you make an equation that says y equals 1x minus 5? I don't care if you put the 1 there or not. But technically, that's considered unsimplified. I don't know who made that rule, but that's just what it is. But anyway, for substitution purposes, so you've got your 3x's. You throw them in place of x on each one. Subtract 5 from it. You'll get your y's. You're good to go. All right? And make a note somewhere that that is our stopping point for today. Okay. As far as we got. So we'll pick back up on Wednesday. And now you're starting to see why there's no lab for this open yet. Kind of heavy. Takes a while to get through. And you got, technically, you got 2 assignments open right now anyway. Right? You got Probability and Stats Lab 3 that's due tomorrow night at midnight. And then you've got your test that opened up today as well. It closes on the 14th. All right? Any questions? All right. Then have a good rest of your day.